past 10 to 12 years, many of our leading semiconductor companies have become fabless. In other words, they don't fabricate the chips inside US anymore. A lot of security issues are associated with this. There's a lot of vulnerabilities in the way this design and fabrication is happening. So microchips or what is known as integrated circuits or ICs could be basically going through various countries to be designed, and then eventually goes to some other countries to be fabricated, packaged, tested, and then goes into the electronic component supply chain. Think about military devices. They're using many of these high-grade integrated circuits, and imagine that some of these integrated circuits are being designed and fabricated in some other countries, but being used in missiles here. It's frightening. In CSTAR, which stands for Center for Security, Testing and Reliability, we basically address various issues. Issues such as development of quality test for in ICs. Each IC must go through a rigorous test before it actually shipped into the market. We also focus quite a bit on the security issues related to integrated circuits. Using highly specialized equipments, we test the chips to ensure they meet the required specification. This device is called automatic test equipment. It allows us to be able to test ICs functionally and structurally. It has 512 pins. That means it can test chips that have up to 512 inputs and outputs. And each of these pins that you can see here, they can be configured and controlled and be able to connect to every one of the pins that we have on this chip to be able to send in data and receiving data from the chip and help us to be able to perform our test procedures. So I'll focus first on the hardware Trojans or what is known as malicious inclusions in our circuitries. The chips are being designed in various sites, design sites distributed across the globe. Hardware Trojan can be inserted into an IC during any step of the design process and fabrication. Hardware Trojan can act like a silicon time bomb. It could potentially destroy an electronic system when it's in the field. Or it can also act as a backdoor where it can send out secret information to adversary. To detect hardware Trojans, we develop novel methodologies that can extract circuit parameters, and by analyzing those circuit parameters, we will be able to identify circuits that are being tampered. In addition, we develop novel sensors. The sensors are inserted into the chips. Any changes to any part of the circuit could potentially impact sensors specification, and by analyzing those specifications, we would be able to say with a high confidence whether those chips have been tampered. System integration relies on high quality integrated circuits. But today, it is very difficult to say whether the chips that we put in our systems are recycled or not, whether they're counterfeit parts or not. In about 5 to 10 years, electronic e-waste could potentially be one of the major issues that world leaders have to deal with. Recycled ICs pose security and reliability issues to our electronic systems. So take automotive industry as an example. Automotive industry has a strict requirement of at least 15 years of lifetime operation within the specification for a chip. But if a recycled chip comes into the supply chain and potentially be used in anti-lock braking system or an airbag controller system, and if the chip has already been used for a couple of few years, and considering the fact that these chips have been taken off of the scrap board, under very harsh condition, which potentially further degrade their performance, this could have a catastrophic impact, and in fact could potentially cause loss of human lives. So we're talking about a global tsunami of discarded electronic products, an amount estimated at tens of millions of tons annually. The used chips find their way into electronic component supply chain, and from there into new electronic products. As for recycled ICs, we develop methodologies to be able to measure the change that are happening in the IC's specification. This is one of the ICs that we actually try to test them. And here we have sensors in the chips. The sensors in the chip will tell us that whether the chip has been used. If the chip is being used in an electronic device before, it has experienced some aging. And by measuring the specification of the sensors in the chip, we will find out whether the chip has already been used or not, and if it is, for approximately how long this chip has been used.